Sustenance fishing is a cold, hard, unforgiving life. It hasn't been easy, but there's absolutely no other way to feed my family. I haven't eaten in over 21 days. I finally got you now, big boy. What a nice kill. We better skin it so we can eat it for dinner tonight. Yeah. Just what I like to see in a nice, healthy specimen. I've developed a sick curiosity as to the average value of the velocity of my fishing line. What's even crazier is that I know the equation that models acceleration in meters per second squared. I have it all written down on this convenient whiteboard. Here we have a to the x equals x squared plus 4, the acceleration of my line, in meters per second squared. Now, if I want the average value of the velocity, I have to set up the integral of this lovely equation, and then I need to do 1 over the top value here, which is 2, and the bottom value. 1 over 2 minus 0, 1/2. I have to multiply whatever lovely values I get in here by 1/2. Here I took the antiderivative of this equation, and then I plugged 2 and 0 in on this other whiteboard over here. When you plug 2 into that equation, you get 32/3. Plug 0 in, you get 0. You multiply this by 1/2, 32 over 6. The average value of my velocity of the fishing line from t equals 0 to t equals 2 is 32.6 meters per second squared. Yes!
After a successful day of fishing, I decided to go back to my village.
Fishing license? Of course, sir.
What is this? Oh no, there's a sharp turn coming! Darn, he's too fast. I need to find out how fast I need to go to catch up to that menace. So, I am approaching this right angle turn from the north, and Tom is heading directly east after making the turn. I know I am 0.05 miles north of the turn, and he is 0.04 miles east of the turn. I also know that I am traveling 35 miles per hour, and he is traveling 15 miles per hour, which I determined with my radar gun. Knowing this, at what rate is the distance between me and him decreasing? First, I will draw a right angle triangle and model the situation with it. I label my distance from the intersection as x, and his distance from the intersection as y. To find z, we use the Pythagorean theorem of x squared plus y squared equals z squared. I then find z to be 0.064 miles. Then I find the derivative of this equation with respect to time. So the equation becomes 2x dx over dt plus 2y dy over dt equals 2z dz dt. Plugging in all the known values allows me to solve for dz dt, which gives me a value of negative 17.969. This means the distance between me and him is decreasing at a rate of negative 17.969 miles per hour.
Neptune, I'm trapped!
Is that good?
Now you gotta go a little farther.
That's one less fish to fry.